All right, we're going to try another one of these examples where we determine the type of function and then we come up with the function that models the data. So we're going to see if our first differences are constant, the second differences are constant, or we might get all the way down to it being exponential and are the ratios of our y values constant. First, let's check our x's. Our x's are all increasing by 1. That's what my +1 means. There's my check to say that we checked it. And now let's find our first differences. So I'm going to extend my table. And let's take a look at what the first differences are. So we start with our second y value, 89.5, and we subtract the one before it, 100, and we get negative 10.5. Then we'll take our 78.9 minus 89.5, and we get negative 10.6. That's pretty close. 68.4 minus 78.9 gives us negative 10.5. And then our 57.8 minus 68.4, we get negative 10.6. So here's another example where the differences are roughly constant. So we're going to go with that. Our first differences are roughly constant. So a linear function best models the data. So we can use our calculators to help us get the function that represents the data. We're not going to do a quadratic regression because a quadratic function doesn't model this data, but we're going to do a linear regression. And I'm going to show you how to do that on your calculator. All right, so we determined that we had a linear function from our table of values. So we're going to go into our calculators. We hit Stat. We want to edit. So hit Enter on Edit. And here is that table of values. We're putting the x coordinates in list 1, the y coordinates in list 2, and we are going to have the calculator do a linear regression for us. So it's going to come up with the best linear function fit to this data. So we go back to Stat. We're going to arrow over to Calc. Now you have seen we've chosen option 5 for a quadratic regression if we know that our table of values is representing a quadratic function. So what we want now is a linear regression. So you have two, this LINREG option 4, and then down here option 8. We're going to pick option 4 because this is going to be most familiar to you guys in slope-intercept form. AX plus B, instead of an M, they just use, their A and their B values. So this will be our slope and this will be our y-intercept. So we're going to arrow down to 4. We're going to tell the calculator we want a linear function to fit this data. From list 1 and list 2, we go down to calculate. And here's our y equals AX plus B. They're telling us here's the equation. Plug this in for your A, plug that in for your B, and you will have a linear function. Okay, so we can see that we're going to have the form y equals that AX plus B in the video, and the A value is negative 10.55. So negative 10.55x. Our B value is 100.02, so plus 100.02. And here is a function that best models the data, and it is linear. It's an x to the first power,
and our calculator calculated the best linear model for our data.